Hello friends, today we'll see mathematical induction. Mathematical induction is the process or technique to prove theorems or statements mainly involving natural numbers. So let us see this mathematical induction by an example. So let's say I want to prove this theorem about natural numbers, that is sum of first n natural numbers is equal to n into n plus 1 by 2, that is prove that 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2. So any mathematical induction process or any mathematical induction proof has three main steps. So first step is called as induction basis. In this step we prove that this theorem is true for the base case. Base case means smallest value. For example, smallest natural number is 1. We prove that this theorem is true for n is equal to 1. That's called as induction basis. Second step is induction hypothesis. In this step we prove that we assume that this theorem is true for some k. That means this is, for example, true for first k natural numbers. So that is induction hypothesis. The third step is called as induction step. In induction step we prove that this theorem is true for k plus 1. Here we, in hypothesis, we assume that this theorem is true for k natural numbers or first k numbers. In induction step we prove that this is true for k plus 1, and while proving this we will take help of this hypothesis or assumption. So let's try to prove this now by using these three steps. The first step says induction basis. Prove that this theorem is true for n is equal to 1. So here n is equal to 1. So LHS will be equal to 1. It was 1 plus 2 plus 3 up to n on LHS. So we are taking only first natural number, that is n equal to 1. On the RHS we have n into n plus 1 by 2. So that is equal to 1 into 1 plus by 2, 1 plus 1 by 2. So that is 2 by 2, that is 1. So LHS is equal to RHS. Therefore this statement is true for n is equal to 1, that is S of 1 is true. Statement or theorem is true for 1. Step 2. In step 2 it is hypothesis. Here we assume the statement is true for k, right? S of k, S stands for statement or theorem, is true for k, that is 1 plus 2 plus 3 plus up to k is equal to k into k plus 1 by 2. Substitute k in place of n because this theorem we are assuming is true for first k natural numbers. Now the step number 3 is induction step. In induction step, we have to prove that this statement is true for k plus 1. Here, if we are assuming it is true for k, in this step we have to prove that it is true for k plus 1. Let's do this. So step 3. So on the LHS we will have, that means what we have to prove, let me write this first. What we have to prove is prove that 1 plus 2 plus 3 plus k plus k plus 1 is equal to k plus 1 we had in the on the RHS we have n into n plus 1 by 2. So in place of n we are substituting k plus 1. So that is n, we have like this on the RHS, n into n plus 1 by 2. So in place of n we are substituting k plus 1 because we are going till k plus 1, sum of first k plus 1 natural number. So that's why in place of n substitute k plus 1. So in place of this one again k plus 1 plus this one will be 2, k plus 2 divided by this 2. So that we have to prove. This LHS will be equal to this. So let's write LHS. Now in the LHS we have 1 plus 2 plus 3 plus up to plus k plus this k plus 1. But in the induction hypothesis we assume that this is the theorem is true for first k natural numbers, or this is equal to k into k plus 1 by 2. So let's substitute this here. Substitute for this from hypothesis. This is equal to k into k plus 1 by 2. So therefore LHS becomes, for this substitute k into k plus 1 by 2 plus this k plus 1. So do the cross multiplication. So it will be 2 into this, and we have in the denominator 1 here. So this 1 will multiply this term plus this 2 will multiply to this term. So we have k plus 1 bracket common in both term. Take that out. Sorry. So k plus 1 taken out. From this first term we'll get k, and the second term will have 2 divided by this 2, and which is equal to our RHS. If you see, let's see the RHS. This is our RHS, k plus 1 into k plus 2 divided by 2. That's what we wanted to prove. So k plus 1 into k plus 2. Hence S of k plus 1 is true. S of k plus 1 means the theorem is true for k plus 1. So that's how you prove the theorem by using mathematical induction. First, prove that theorem is true for a base case. Base case means smallest possible number. And in the second step we have induction hypothesis. In induction hypothesis we assume that this theorem is true for some k natural numbers or some value k. In the induction step we prove that this theorem is true for k plus 1 natural numbers. So while proving this we have to take help of the induction hypothesis. So we'll see more examples in the next videos. So thank you for watching.